Assalamu alaikum. So today I will be performing my lab number 3 of DLD, which is verification of De Morgan's law and implementation of Boolean function through logic gates. So using logic gates I will be basically creating circuits for these equations, which is x plus y bar equals to x bar dot y bar and x dot y bar equals to x bar plus y bar. So let's now open the Proteus and implement these equations. Let's create a new project. I will give the name TLD lab 3, keep the landscape A3 and create a new project. Okay, so first of all, to create the circuit we will need inputs. So let's search push buttons to toggle the inputs. Push button, pick this from here. Then we'll be needing resistors. Pick this one here. And then you will be needing NOT gates for the complements. So for that 7404, take here. Then you will need some AND and OR gates. So 7408 for the AND gate. Keeping in check the simulator models for everyone. And for the OR gate 742 and a LED to check the output. So a blue LED here, and yeah, I think that's it. So now let's create the circuit for the first expression. So let's first create for the left hand side of the first expression, which is x plus y bar. So we need two inputs. For that we will pick up two DC generators, 1, 2, name this one x and give it an input of 5 volts. Name this one y, give this an input of 5 volts. Then let's place our push buttons so that we can toggle the input. Two push buttons in front of the both inputs, connect them to each other. Then we know the first thing, if x plus y, so we'll take an OR gate for that. OR gate here to perform the x plus 1 function, and then we have the complement on the whole expression. So at the output we'll place the NOT gate and connect it, and then the LED at the output to check our outputs. Then a ground terminal to provide ground for the circuit. We will connect both our resistors here from the inputs to the ground to avoid the collection of charges at the pins of the gate. So 330 ohm resistors connecting to the ground. Similarly, now we will perform the right hand side of the expression, x bar dot y bar. So again we will need two DC inputs. Again I will name them x Again, two push buttons. Connect the inputs to the push buttons. And now X bar, Y bar, so we will place our NOT gates. For the NOT input, for the bars complement of each input, and then we can see the multiplication sign in between. So for that we will take the AND gate, which performs a multiplication function. So connect the NOT outputs with the AND gate, and then at the output of the AND gate we'll place our LED, and then a ground terminal. Again, our resistors for the same purpose for the which was in the first circuit. I think I made an error. Need to connect resistor from here. Yes, now it is grounded correctly. Okay, again for the second Y input. So now let's run the simulation. Our output should be same for both the circuits. So now let's see. So when both, we can see inputs are 0 for both the circuit, the LED is on for both the circuits. So same behavior, closing one of input X of both LEDs, you can see that inputs, you can see that LED has switched off, and the same outputs in both the circuits. And when both the inputs are high, again same output, and you can see the fourth condition, again the same output. So first expression has been verified. Now let's move toward the second one. So now this is our second expression. So let's perform the left hand side first. X dot Y not. So I will move a bit here, or let's remove this all. Let's keep the push buttons and the DC sources at their places. Okay, so X dot Y whole bar. So X dot Y means X and Y. So an AND gate at the input, so this will work as X and Y, and then NOT for the whole. So output NOT gate at the output, gain an LED and a ground terminal. Okay, let's connect them. Resistors, and now let's implement the right side, X bar plus Y bar. So NOT gates for the X bar and Y bar. So set X bar, Y bar, and we have our addition sign, so OR gate. Ground terminal, our resistor resistors. Okay, so we have created both the right and left hand side of the expression. So now let's run the simulation and check that if both the circuits should behave identically. So let's see. So we can see when one input is high, which is x is high, y is high and x is low. In both the cases we can see the output is same, that is high. Both the inputs are high, you can see both the outputs are low. Let's change the inputs again. X this time x is high and y is low, so we can see the same outputs. Now again, when both the inputs are low, you can see the outputs are high. So again you can see that the both right hand side and left hand side are equal, as their circuits are behaving completely similar. Further in this lab, let's we will see how to implement Boolean expressions. So first we have this expression f equals to x plus y dot z. So we'll implement this Boolean function and make it circuit. So let's remove this. So we need three inputs x, y, z. So we will take a DC generator, place three inputs here, name one x, value of 5 volts, name this one y, value 5 volts, and name this one z and give it a value of 5 volts. Place our push buttons and connect them with our inputs. Here. Now let's look at the expression again. X plus y, and okay, so y for y dot z I will use an AND gate for the dot function. So here is the AND gate, and the output of AND is now adding with the x. So for addition, the OR gate. So our x and the output of y plus z, y dot z, sorry. So will be the input of our OR gate, and we connect the LED. And then a ground terminal. So now let's zoom in a bit. Now let's run our simulation, and we can see that according to this, when y is 1 and z is 1, the output is 1. So let's check this. When y is 1, we have forgotten to place our resistors, so let's place our resistors and ground them. So placing our resistors. So now let's run the simulation. So when y is 1 and z is 1, the output is 1. We can see here. So let's implement this. Y is high and z is high. We can see the LED lights up. Then x is 1 and other both inputs are 0. So now let's check for that one. You can see again the LED lights up. So our circuit is being, we can see, implemented as it is shown in the truth table. So let's try this 0 case scenario, and we can see that at 0 0 1 output is 0. So we have verified it with the truth table, and we have verified that the circuit we have created is correct. Now let's move towards the other part of this lab. So in this, now we have to implement these two functions. So let's implement first function 1. So we have a, b, c, d 4 inputs. So let's remove this part only, and let's add another input. A push button with it. Okay, now a bar b plus c bar d. So for a bar b, let's rename these a, b, c, and this one is d. So a bar b, so for a bar, let's connect a NOT gate for a bar, and a bar b, which means multiplication, so AND gate for a bar b, and c bar d, so again NOT gate for c bar, and c bar d again, and AND gate, and all the outputs of these AND gates are being added, so an OR gate. Let's place the LED, ground terminal, and now let's place the resistors and ground them. So first from here, second from here, third resistor here, the third input, and fourth input here. Okay, now let's look at the truth table of the first function. So we can see that here, when all the inputs are off and only D is on, the so you can see that only D is high and all the others are low, and we have the output 1. Let's check another scenario. So for this one, when B is on and others are off, you can see the 1 is output. So let's try that one. So here we can see again the output. So similarly, we can look at other combinations, and you will be able to see that our output is correctly being verified. So our circuit F1 expression has been designed successfully. Now let's move towards the F2, a bar b bar plus c bar d bar. So it's basically the same expression, only the inputs B and D are also now barred. So now we can simply change this by adding NOT gates at these inputs. So let's do that. Selecting the NOT gate here and just simply adding it at the inputs D and E. And now let's run, and now our design for F2 expression is completed. We can see that if the circuit we have designed is correct or not by creating a truth table for this expression and verifying our outputs accordingly as we did for the expression F1. So our lab 3 has been simulation part of the lab 3 has been completed. We have implemented all the expressions given in this lab and we have designed circuits for them. We have proved the De Morgan's law successfully and we have shown how to create Boolean circuits from Boolean expressions. So thank you.